We are going to continue looking at our rational functions and their graphs today. We're looking at graphing the most basic reciprocal function. So looking at y equals a divided by x. And then we're also going to look at doing some translations of that. Okay? Stretching it, compressing it, reflecting it, shifting it left, right, up, down, all of those. Okay? So graphing rational or the reciprocal function, and then looking at transformations of it. So functions that model the inverse variation form, that y equals a divided by x, or f of x equals a divided by x. That's what we're going to start out looking at. Okay? That's a basic reciprocal function. Why do we have the restriction that x cannot equal 0? Yeah, can't divide by 0. Okay? It says they belong to a family whose parent function is the reciprocal function f of x equals 1 divided by x. That's our most basic one. Okay? We call that the parent function. We can transform it. We can do stretches, compressions, shrinks, reflections, horizontal and vertical translations. We're going to look at all of those different translations today, or transformations. It fits our same basic pattern. We've looked at all different kinds of functions this year, but we've translated them all the same way. Okay, so if we think of y equals a divided by x minus h plus k, now our restriction is that x cannot equal h because that would create a 0 in the denominator. We can't divide by 0. We are taking that inverse variation function and we're going to just translate it. The graph of y equals 1 divided by x, our basic reciprocal function, is shown in this picture. I'm going to pause the recording in a second. What I'd like you guys to do is, looking at the picture, identify all of these things. Horizontal, vertical asymptotes, x and y intercepts, domain and range. Talk about that at your tables. All right, so looking at our picture, our branches seem to be approaching the x-axis, yes? And they also seem to be approaching our y-axis. Those would be our asymptotes, right? Lines that our graph is approaching as we move away from the origin, or in the case of the y-axis, as we move close to that y-axis. Okay? What's the equation for the horizontal asymptote? X equals 0 would be my vertical one. X equals 0 is the vertical asymptote. What's the horizontal one? Y equals 0. Yep. Do we have any x-intercepts? There's no place where our graph's going to touch the x-axis? Okay. Do we have any y-intercepts? No. How about domain and range? Everything but 0. Agree, disagree? We've already said that we can't be on the y-axis, right? It's a vertical asymptote, so we know that y can't equal 0. We said we can't be on the x-axis, so x can't be 0. Your asymptotes and your domain and range will be tied together. Wherever there's a vertical or horizontal asymptote, that is a value you have to restrict out of your domain. Okay? And range, I should say. Can you picture the asymptotes changing if we do a stretch or compression? Would that cause those asymptotes to change? No. Do you remember when we talked about our graphs last week? What happens as that A value got bigger? What happens to the branch? The branch moves farther out, right? But we still have those same asymptotes. What would cause the asymptotes to change? Which of our transformations? A move up or down would affect your horizontal asymptote. It's going to move along with your graph, up or down. Any left or right movement will move your vertical asymptote. Okay? So stretching, compressing, or reflecting over the x-axis doesn't change the asymptotes, but left, right, or up, down shifts would. Okay? And if we shift those asymptotes, that means our domain and range change, and it means we may end up with some x or y intercepts. Okay? All right, so we're going to start out looking at our basic reciprocal function. We've changed one thing. Instead of 1 over x, we are making this 8 divided by x. Y equals 8 divided by x. X cannot equal 0 in this case. It says to identify the x and y intercepts, the asymptotes, and the domain and range. So we're going to start out making a table. And again, for this first one, we're going to have a fairly extensive table, but we'll be able to shrink that down a little bit as we go today. I'm going to choose values for x that I can divide into 8 nicely. Okay, so I'm going to start out with -8, -4, -2, -1. And then I'll use the positive versions. Make sure when you're graphing these functions that you always do some positives and some negatives. Otherwise, you may not see both branches. All right. If we take 8 divided by -8, we get -1. 8 divided by -4 would be -2. 8 divided by -2 would be -4. And 8 divided by -1 would be -8. All right. If we plot those, we can see 1/2 of our picture. My board's off again. All right. If we plot our positive ones, 8 divided by 1 is 8, divided by 2 is 4, divided by 4 is 2, divided by 8 is 1. All right. So we've plotted our points from our table. Have we changed our asymptotes? So what would the horizontal asymptote be? And it has to be an equation. Horizontal would be y equals 0. Vertical asymptote, x equals 0. Common mistake, you flip those two around. Okay? Keep in mind that on the y-axis, your x-coordinate is always 0. Doesn't matter what point you're on, your x-coordinate is always 0. So that's your equation, x equals 0. Domain and range, x and y intercepts. How about intercepts? Do we have any? Okay. What's the restriction for our domain? X can't be 0, and our range? Y can't be 0. All right. Check in with the people at your table. If you're all okay with that, go ahead and try this one on your own. All right. We won't do quite as extensive a list here. All right, so if we put a -2 in for our x value, you should have had -6. 12 divided by -4 would be -3. Divided by -6 would be -2. Yes? And we just get the positive version as well. So plotting those points, -2, -6, -4, -3, and -6, -2. So again, we have a branch in this quadrant. 2, 6, 4, 3, 6, 2. All right. So did our asymptotes, any of this stuff change? All right. So horizontal asymptote was y equals 0. Vertical asymptote, x equals 0. No intercepts yet? And domain and range. X not equal to 0, Y not equal to 0. We okay with those? All right. Each part of the graph is called a branch. Know that with all of these rational functions, and again, we're looking at just a basic reciprocal function today, but all of these rational functions where you have variables in the numerator and denominator, we can have some very interesting graphs. Make sure you're seeing all the parts of it. The best way to do that is to make sure in your table you have some positive and some negative x's. Okay. The branches for our parent function, y equals 1 divided by x, are in quadrants 1 and 3. We said that stretching, compressing do not change the quadrants, but reflections would. Okay? So what we're going to do on this one, we are going to graph that parent function, and then we're not going to graph each of these individual ones. We're just going to look at what would change on it. Okay? So if we were to graph y equals 1 divided by x, let's put in negative 1/2, negative 1, and negative 2. And then our positive versions. 1 divided by negative 1/2 gets us negative 2. 1 divided by negative 1. Negative 1. 1 divided by negative 2. Okay? And then our positive versions. All right. So negative 1/2, negative 2, negative 1, negative 1, negative 2, negative 1/2. 1/2, 2, 1, 1, 2, 1/2. So our reciprocal function, y equals 1 divided by x, our graph is very tight in there next to the x-axis, or next to the origin, and our graph is very close to those axes. All right. What would change if we change our a to being a 6? What kind of transformation are we doing? We are doing a vertical stretch. Do the quadrants change? No. So we are still in quadrants 1 and 3. What about if a is 25/100ths? We've made it smaller, so it's going to be pulled even closer into the origin. Vertical compression. Still in quadrants 1 and 3. If a is -6, what happens? What kind of transformations have we done? It reflects across our x-axis. And if we reflect it across the x-axis, now the branch that was in quadrant 1 is going to end up down here, and the branch that was in quadrant 3 will end up in quadrant 2. Yes? So we've changed our quadrants here. Now we are in quadrants 2 and 4. So we've done a reflection, but we've also done what? Vertical stretch. All right. We're going to start putting this all together. That a value is our stretch, compression, and reflection over the x-axis. We've talked about our h and k being our left and right up and down shifts. So we are looking at this as our main transformed reciprocal function. Okay, our a value on top will be our stretch, compression, or reflection. H is your left and right move. K is your up and down move. Notice that our restriction is that x cannot equal h. Again, putting an h value in there will cause a 0 for the denominator. We also said earlier that any kind of left, right, or up-down translation will cause the asymptotes to move. So it's important to figure out where those are going to move to. Based on my equation, what kind of transformations have we done? We've shifted it, translated it left 1 and down 2. Okay? We are going to start out by graphing the parent function. Y equals 1 divided by x. Again, we're going to just choose those 3 values and their positive versions. That we had on our last example. So -1/2, -2, -1, -1, -2, -1/2, and our positive side. You will be doing a lot of translating of this, so recognizing those key points for the y equals 1 divided by x function will be helpful. All right. Now we said we are going to shift left 1. That means my vertical asymptote here where y equals 0, sorry, where x equals 0 is going to shift left 1. So what is the equation for that new asymptote? X equals -1. And then we said our horizontal asymptote is going to shift down 2. So now we have the equation y equals -2. So even without shifting our points yet, we already know our domain and range because we have to restrict the values where we had the asymptotes. So domain would be that x cannot equal -1, and range would be y cannot equal -2. All right, let's move our points. Shifting them each left 1 and down 2. All right, as you graph these, make sure that you're approaching those asymptotes but not actually touching them. All right, you want to show that you're getting closer and closer to it without crossing them. All right, I'm going to pause the recording. I want you guys to try the next one with your partners. All right, which way did we transform this? We went right 4 and up 6. So if we take those parent function points that we've been using, and we want to shift them right 4, what is the equation for this vertical asymptote? X equals 4. And then we shifted up 6. And the horizontal asymptote would have an equation y equals 6. Shifting our points. These two we have at 1, 1 and -1, -1. All right, so if we think of them being in a similar position with our new asymptotes, we know where those dots are. And we should be able to get the 2 on either side of them. Okay. All right, domain and range. What are the values that we can't use for x? Can't be 4 and y can't be 6. Yes? All right, if we know the asymptotes and the value of a, we can come up with our own equation. So in this one, they're telling me that I'm starting with a y equals 2 divided by x. So I've done a small vertical stretch on it, on the parent function. Now they're saying come up with an equation for this. So looking at the graph, can you tell which way we've shifted it? We've gone left and up. Now watch your scale carefully. How big is each tick mark in this picture? 2. So we've gone left how much? 3. So left 3 and then up 4. So if we know that the a value was a 2, how do we change that equation to show that we're going left 3? Plus 3 with the x. And how do we show that we're moving it up 4? Plus 4 on the end. Yes? All right. So for our second one here, we're again starting with y equals 2 divided by x. Which way have we moved it? I heard right 1. How would we change our equation to show a right 1? X minus 1 would be a right 1 move. And then which other transformation? Down 4. So at the end we need minus 4. All right. Our last one, we're going to look at an application. It says the rowing club is renting a 57-passenger bus for a day trip. The cost of the bus is $750. 5 of the passengers will be chaperones. If the students who attend share the bus cost equally, what function models the cost per student C with respect to the number of students N who attend? That's one of our questions. Then it says, what is the domain of the function? And it's also asking us to figure out how many students have to take the bus if we want the cost to be no more than $20 per student. Okay? So there's 3 things we have to come up with. Let's start with the domain. How many people can fit on the bus? 57. But of those 57 seats, 5 of them are being used by the chaperones. So in terms of the number of students that could go, we have a maximum of 52. What would our minimum be? Of students. How many students would be the minimum? If I say I'm going to take 0 students, am I going to rent a bus? No. So 1 student needing to go on the bus would be the minimum I could have. Does that make sense? So my domain, I would say my N values have to be somewhere between 1 and 52 in terms of the number of students going. How much did the bus cost? $750. If 1 student goes on the bus, how much is that student paying? $750. Better be a really nice trip. If 10 students go, how much does each student have to pay? $75. So as the number of students that ride the bus increases, what happens to your cost? It's going down. The cost per student decreases. So my total cost per student, I have to take the $750 and divide it by what? By the number of students going. Yes? That's what you just did. 750 divided by 1, 750 divided by 10. That's the function that models this situation. 750 divided by n. Then the third part of the question said, how many students have to ride the bus to make the cost per student no more than $20? No more than 20 means what inequality? Less than or equal to. So we want our 750 divided by n to be less than or equal to 20. Well, you told me a minute ago if 10 students go, they pay 75 bucks. So it has to be more than 10, right? No more than 20. So my 750 divided by n has to be less than or equal to 20. How do I solve that for n? The n has to get multiplied up here, and then what? The 20 gets divided down. So 750 divided by 20 will be less than or equal to n. What is 750 divided by 20? All right, so if only 37 students go, can we keep the costs under the $20? No. So we have to round up to 38 students. Our n value here has to be greater than or equal to that. So the smallest I can have is 38 students. Okay? There is your assignment.